All right, so this is application problems. So I know up here on the top it says solving quadratic word problems, but what we're doing here is we're going to end up with equations that are going to be in the form ax squared plus bx plus c equals 0. So we know now that we can factor this, and this gives us our values of x. So we're going to go in here, we're going to look at some applications. So it says, the area of the rectangle is 84 square inches. Find its length and width. So we know that the formula for the area of a rectangle is length times width. Well, I have a length. My length here is x plus 3. And I have a width, and my width here is x minus 2. And I know that the total area is going to equal 84. So I can go ahead, I'm trying to solve for x here. And so I can't just subtract 2 or add 2 or do anything. I actually have to FOIL this out. So step 1 on a process like this is I'm going to FOIL this left side. So end up with x squared plus x minus 6 minus 84 equals 0. So if you need to take the time to actually FOIL this out, I can see that this is 3x minus 2x, so that's where I have 1x here. Okay, so simplify this up. And I have 84 plus 6, which is 90. So now what I want to do is I want to find my two values of x that make this true. Okay, so what I'm going to do here is I'm just going to factor this. So if I factor this, I know my two values of 90 that are going to give me a 1 are going to be 9 and 10. 9 and 10. 10 is my positive, and this is my negative. So when I solve this, I have x equals 9 and x equals negative 10. So nothing new, except for now we have to evaluate this a little bit. So we have to go back and think about whether this makes sense. So I have this value of x equals 9. Well, if I have x equals 9, I can plug it in here, and 9 plus 3 is 12. And I can plug it in here, and I see that I get 7. 9 minus 2 is 7. So I have two lengths here, and these are both in inches. But what happens when I put in negative 10? When I put negative 10 in over here, I would have negative 10 minus 2. And this would give me a length or a width of negative 12. And that doesn't make sense. This would say I have a negative length. So obviously I don't have a negative length. So we're going to say that x equals negative 10 is extraneous. So the question here says find its length and width, so 7 inches and 12 inches, and we found that only using x equals 9. So once we have an answer, we have to go back and evaluate it and see if it's going to be extraneous or not. All right, let's look at this next one. It says the perimeter of this quadrilateral is 120 centimeters. Find the lengths of the sides. So perimeter, I'm going around the outside, and I'm adding everything up. So I'm going to start right here, and I would have x plus 5, x squared minus 3x, 3x minus 8, and then x plus 3. And the whole thing, all the way around, is 120 centimeters. So what I'm going to do now is I am going to just combine like terms. So I have my x squared term here, and then I have 1, negative 2, that goes away, so I have 1 and 1, so plus 2x. And then I have 5, negative 3, 3. So all my constants cancel out, and this equals 120 centimeters. Well, for me to solve this, remember, has to equal 0. Okay, so now what I want to do is I want to find my two values that are going to give me 2, and I see this easily. It's 10 times 12. 10 times 12 is 120, and the difference here is going to give me 2. So my values are going to be let's see, x plus 12 and x minus 10 equals 0. So what this tells me is that x can equal negative 12 or x can equal 10. So now if we go back over here and we look at this value of negative 12, if I plug it in, well, I can plug it into any of these, but if I plug it in here, I have negative 12 plus 3. So that would give this dimension a negative length. So we know that this is going to be extraneous. All right, so now it's asking you to find the lengths of all of your sides. So I'm going to take this value of 10 and plug it in. So this is 30 minus 8, so 22, and 10 plus 3, which is 13, 10 plus 5, which is 15. This is going to be 100 minus 30, so this length is going to be 70. And these are all in centimeters. I didn't put the units down, but those are all going to be in centimeters. Okay. You go ahead and pause the video and you do number 3. It's still dealing with perimeter, so this isn't anything new. All right. I'm not really going to talk through this. I think it's pretty self-explanatory. Pause the video here if you need to look through it, but here are my lengths, and these are all going to be in feet. Okay. All right, let's go down here to the circle. We have a different formula now. It says the area of a circle is 25 pi square kilometers. So I have to know area of a circle is pi r squared. And what it's saying is that the area is 25 pi. So my r value here is just an x. So if I plug this in, I'm going to get pi x squared equals 25 pi. Now let's look through this again. So here's my formula of a circle, area of a circle, and it's pi r squared. But r, in this case, is just the radius, and the radius is x. So I'm going to take this r squared and I'm going to plug in x. And it tells us the area is 25 pi. So it leaves the answer in terms of pi. So my area is 25 pi. So if I'm solving for x, I'm going to divide both sides by pi, and I get x squared equals 25. So now what I would do is take the square root of both sides, and I get x equals plus or minus 5. Well, obviously I can't have a negative 5. I can't have a negative radius. So I'm going to say that the radius, which is x, equals 5 kilometers. And I'm getting that from my the unit from my story problem, like everything else. Okay? All right, let's flip it over, see what we have. Okay, so we have some words now. So what this is saying is the length of a rectangle is 7 centimeters less than twice its width. So this less than is what I call this turnaround phrase. So that means I'm going to subtract 7. Its area is 30 square centimeters. So we know now that area is length times width. Okay? And what we know is that the length is 7 centimeters less than twice its width. So twice its width minus 7 centimeters. Okay, so what I have here is my width times twice my width minus 7 centimeters equals 30 square centimeters. So when I distribute this through, okay, so now I want to go in here and I want to factor it. So I have 1 and 2, and let's see, I'm going to use, let's just try 3 and 10, see what happens. 20, nope, that doesn't work. So let's go back to closest one, 6 and 5. So this would be 12 minus 5. Okay, so W, 2W, and I want this to be 12, so 6 goes here, and 5 goes here, 7's negative, so it looks like this. Okay. Oh wait, hold on. One of these has to be positive. 12 plus. Okay, so my values are going to be, W is either going to equal 6 or negative 5 over 2. Well, we know right away that we can't have this value of 5 over 2. So we're going to have the value of 6. But it says find the dimensions. So I'm looking for the dimensions. I'm not looking for just the width. So I have to also find the length. So this is going to be 2 times 6 minus 7, which is 5. So we know that the width is going to be 6 centimeters and the length is going to be 5 centimeters. Okay. I'm going to go ahead and pause the video again, and I want you to work 6, 7, and 8, and then come back online and check your answers on those. Okay, let's look at these. So with the first one, the only thing that makes this hard is knowing the factors of 112. And so I'm not going to lie, I used my calculator to figure out what these factors were. And so when I plugged these in, I got 7 and 16, right? So we see that this one's extraneous, so we end up with width of 7, length of 16, okay? With this next one, it's kind of nice because you're just going to add up the sides, and we know that it equals 12. So I ended up with negative 2/3. I plugged it in this just to make sure that it was really extraneous, and it is. Now this next one, this area of this rectangle, this one's a little odd because we don't actually equal a number, we're equaling another expression. So the way I have this set up is I have my two sides on this side, and I know that it's length times width, and this is going to equal my area, which is this expression. Okay, so normally we are just going to move all of our variables on one side to try to isolate x, but this time we want to move everything over because we want it to equal 0. So when you factor it, you get x is 5 and x is negative 2. It says find the dimensions, so when I plug that in over here, I would have 2 and 11. And this one doesn't have any units, so this one would have no units. All right, let's look at this last one. It says the length of a rectangle, so the length of the rectangle is 3 more than twice its width. So 3 more than twice its width. The area equals 20. Find the dimensions. So we have width times twice the width plus 3 equals 20. So there's nothing new on this one. 2w squared plus 3w minus 20 equals 0. So my factors here are 1 and 2, and I'm going to just go ahead and try 4 and 5. So this gives me 8 and 5, which is perfect. So w, 2w, I want this to be 8, so 8 minus 5. So w equals negative 4, and 5 over 2. So if I want the dimensions, I can't have a negative width, so this one doesn't work, it's extraneous. So my width is going to be 5 over 2. It looks like there's no dimensions on that one. And then when I plug them in for the length, I get 2 times 5 over 2 plus 3. So this cancels, so this is just my length equals 8. Okay, so these aren't too bad. You just have to see the pattern, know you're going to end up with a quadratic, set it equal to 0, factor it, and then plug it in and find the extraneous solution.